Hello, today I'm going to talk about why pulling the handpiece tip away from the skin is such a bad idea, particularly when treating tattoos. So most handpieces that come with tattoo lasers these days, whether they're Q-switched or picosecond, will have some kind of a focusing lens in the handpiece tip, something like this. And this is a pretty standard setup for pretty much all lasers out there these days. The smaller, usually cheaper desktop machines will have tips like these guys here, but again, it's the same idea as with the larger floor-based units. It doesn't really matter. The point here is that the tips usually have some kind of a lens in them, a focusing lens. So you've got the handpiece tip casing itself, then you've got a lens, usually a concave lens, and then you have a space bar, and this determines the plane in which the spot diameter is the correct size, and that's the spot diameter that we want to apply to the skin surface. And by doing so, we ensure that we will supply the correct fluence, energy density, to the skin. So if we fire in some laser energy, it will meet the lens in the handpiece, and that will then focus it down to some point, beyond which the light will actually expand out again as it passes through the focal point. So the focal point is where the spot size is the smallest possible size or area. So this is always, or pretty much always, at some distance from the handpiece tip itself. And the problem here is that because the spot size diameter is so small, then the energy and the power densities are enormous. The energy density can easily be over 60, 70, 80 joules per square centimetre, which is way too high for the skin. And at these power densities, there is sufficient power density in that small area to start to break down the oxygen molecules in the air. And this is what generates the cracking sound that we hear. And it can be quite loud. Now, the problem is that some people are using their lasers like this, where they're being taught to listen out for this loud cracking sound, and being told that this is the ideal setup. It absolutely is not. At this point, the spot size is far too small, the energy density is far too high, and the potential for skin damage, particularly in the dermis, is great. Where we should be placing the handpiece is here at this point, at the end of the spacebar. The engineers who design these systems design them such that the spacing bar is either touching the skin or just slightly off the skin surface. And at that distance from the lens, they know that the spot size is correct, will deliver the correct energy and power densities. But once you pull the handpiece away from the skin surface, the engineers have no way to know, and neither do you, no way to know what the spot size is anymore, and therefore you cannot have any idea what the energy density is at the actual skin surface. And that is just plainly wrong. So here I am firing the laser at myself and pulling the handpiece away and then taking it back to the skin surface. And you can see that at about 10 centimeters from the surface, the loud cracking noise is very apparent. And then the same goes here for a bit of white paper at about the same distance, which just goes to show that the cracking sound has got nothing to do with the skin, nor the tattoo inks. That there is no good reason to chase this cracking sound. It's just nonsense. You are just much more likely to damage the skin. You won't see the damage immediately, but it's there, and it will eventually manifest itself later on. If you do apply this very small spot size at the skin surface, you will generate huge energy densities and power densities. That's what's causing the noise. It's got absolutely nothing to do with the skin or tattooing, so don't do it. It's completely wrong. Thanks for watching this one. You can have a wee look at some of my other videos and also my blog at mikemurphyblog.com. Thanks so much, Ian. Bye.